Hey everybody, welcome back. This lesson is about a topic we call electromagnetism. Electricity and magnetism are actually two manifestations of the same physical force that we simply call electromagnetism. One force creates the other force in the presence of movement. For example, magnets in motion create electricity. But also electricity, which is just electrons in motion, create a magnetic field. The presence of motion is key. Stationary electric charges, like electrons, if they're not moving, do not create a magnetic field. And a static magnetic field, one that's not moving, does not create electricity. This is described by Michael Faraday's law of magnetic induction. So here's a few examples of electromagnets. These images illustrate the basic form of two kinds of electromagnets. The battery serves as the source of current flow. In other words, the battery is the source of electricity, of electron movement. The copper wire carries the current from the battery through the coils. The movement of electrons creates flux lines that align through the center of the coil, and you can see that in both examples. In the example to the right, however, we have the addition of an iron core that is added to increase the strength of the magnet by concentrating the flux lines. So it's actually very easy to create an electromagnet. It's simply a power source that's a source of current or electron flow, which is then circulated through adjacent copper coils. And that's all you need to create an electromagnet. It's a magnet created by electricity. So here's a question for you. What additional factors do you think might influence the strength of an electromagnet? We've already observed that adding an iron core concentrates the flux lines and makes the magnet stronger, but what else could increase the strength of an electric field created by an electromagnet? Pause this video and try to answer this question on your own. So there's a few things that potentially influence the strength of an electromagnet. For example, not just the presence of an iron core, but really just the type of core material in general. Iron is commonly used, but other types of materials could be used and they influence the magnet strength in different ways. Also, the size or diameter of the core that's used, and then finally, the strength of the electrical current potentially influences the strength of the magnetic field created. Here's another question to test your understanding of this material. Let's look at this situation. An electromagnet is constructed correctly, but it is not generating a magnetic field. What are possible reasons for this failure? Pause this video and take a second to try to answer this question on your own. So if everything is constructed correctly, it must mean that electrons are not flowing through the coil. Because if electrons were flowing through the coil, then we would have a magnetic field. Since we don't have a magnetic field, we know that current isn't flowing. So that helps us to narrow down the situation. Why is it that current might not be flowing? There's two possible explanations. There's either a failure in the current source, in other words, like the battery isn't working, or secondly, there could be a failure in the wire. The wire could be broken, and if the wire is broken, the electrons won't flow, and if the electrons aren't flowing, then we won't have a magnetic field. Something else we should talk about in the context of electromagnetism is really special electromagnets that we call induction motors. Induction motors are a special kind of electromagnet used to create motion. They are very common in numerous devices. So here's how they work. With an induction motor, we have a series of electromagnets called the stators. And these are activated in series, in other words, in sequence, sequentially. And when they do that, it turns a shaft through the center of those electromagnets that we call the rotor. Induction motors are very common. They have numerous applications. Essentially, any device that converts electricity into motion is probably using an electromagnetic induction motor, such as solenoids, fans, CD players, power drills, and many, many more. Induction motors are important in radiography because induction motors are used in the X-ray tube to turn the anode. So that's an overview of electromagnetism and why it matters in radiographic imaging.